All right, here are the solutions to quiz one. I hope that you looked at the solutions. I mean, looked at your quiz already with my annotations, but number one here is number one done with all the work shown and justification. So we know that pi radians is the same thing as 180 degrees. Pi doesn't equal 180, but pi radians is 180 degrees. Now, this is an equation. If I divide both sides by 180, then I can see that pi over 180 radians is 1 degree. Well, if I've got 330 degrees, I must have 330 pi over 180s. So that's 330 times pi over 180, which is 330 pi over 180. 330 breaks down into these two factors, which 30 is a common factor between top and bottom. They cancel out, leaving you with 11 pi over 6. This is a radian measure, not because there's a pi, but because there is no degree symbol. So this is an angle, and because there's no degree symbol, it's a radian, not because there just happens to be a pi there. You can have pi degrees. That would be a really small angle. That's just an angle that has 3.14 degrees. And you can also have 1 radian. You don't need pi to be radians, but there's no degree symbol here, so that means we're in radians. And back to this, pi radians is 180 degrees. This is an equation, so I get to do almost whatever I want. I'll divide both sides by pi. And if I divide the left side by pi, I end up with 1 radian. If I divide the right side by pi, I have 180 over pi degrees. So 3 pi over 4 radians must be 180 over pi of those radians. So 180 over pi radians, because 1 radian is 180 over pi degrees. So 3.3 pi over 4 radians must be 3 pi over 4, 180 over pi degrees. So I'm multiplying. The pi's cancel out. 180 is 4 times 45, so the 4's cancel out, leaving me with just 3 times 45, which is 135 degrees. 2, you want 2 angles that are coterminal, one positive, one negative, between negative 2 pi and 2 pi, such that it goes through the center, the origin, and point A. Now, point A is 120 degrees because you've got 60 degrees here, and another 60 will get you right there. So it's 120 degrees, which is 2 pi over 3 radians. And to find the negative version of that, you just rotate backwards a full circle. A full circle is 2 pi. So I want to subtract 2 pi. And we are using a strategy here. I don't want to write down minus 2 pi. I know that I have a denominator of 3, so I'm going to subtract 6 pi over 3, which is 2 pi. And these two fractions subtract to negative 4 pi over 3. So these are the only two, this is the only solution here. There are many, many, many angles that end right here. But there's only one positive angle between these two angles and one negative angle between these two angles. That's that right here. For letter F, notice F is in between these two, so it's a 45. 45 degrees plus another 45 degrees, a third 45, a fourth 45, a fifth 45, a sixth 45, 7 45s. So to get all the way here, I had to rotate 7 groups of 45. So that's 7 times 45, which is 315. That is 7 pi over 4 radians. So that's and I can use the same logic up here. I would just take 315 degrees times pi over 180 to get 7 pi over 4. And then to find the negative angle, I subtract 2 pi, which is, I can express 2 pi as 8 pi over 4. And 7 pi over 4 minus 8 pi over 4 is negative 1 pi over 4. Draw and label a right triangle. So here's a right triangle. If the sine of an angle is 7 over 8, I have to think, where do I put all these symbols? If you choose to put theta here, then knowing that the sine of theta is 7 over 8, we have to know that sine is opposite over hypotenuse. So the opposite side of this angle is right here. So that would be 7. And the hypotenuse, of course, is the longest side, 8. And I can use Pythagorean theorem to find this leg. So leg squared plus leg squared equals hypotenuse squared. I discover the leg is rad 15. And find the cosine of theta is adjacent over hypotenuse, so rad 15 over 8. Tangent is opposite over adjacent, so 7 over rad 15. We want to rationalize the denominator, which were the directions. So rad 15 is irrational, and I can always multiply by 1 and not change anything. So I'll multiply by 1, and the denominator becomes 15, which is rational. And this is the final answer. You guys did well. You also did well on number 4. You have we should draw a diagram. We're instructed to do that. So here's my tree, and the sun is over here somewhere casting the light. The tree intercepts the light, creates a shadow, which is 35 feet long. And the angle of elevation is 40 degrees. I want to find the height, and I have a right triangle. I'm assuming that this tree is vertically upright, forming a right angle. And if I have a right triangle, I get to do SOHCAHTOA. So I want to find the height in the fastest way possible. The height happens to be the opposite side of this angle, and 35 happens to be the adjacent side of this angle. So that's tangent. Tangent is opposite over adjacent. So the tangent of 40 equals the height of the tree divided by 35. This is the exact height of the tree. That's the exact height of the tree. Punch that in your calculator. It equals about 29. We were asked to round to the nearest foot.